Hello everyone, welcome to the e-lecture series on power quality, module 3. I am Mr. Somnath Hadpe, working as assistant professor in electrical engineering department in Matusri College of Engineering and Research Center, Nasik. In module 3 of power quality, we are going to study the introduction regarding flickers, notches, DC offset and harmonics. Before going into module 3, we'll just take a short review of module 2. In module 2, we covered the various power quality events, their classification. Basically, all the power quality events are divided into two parts. These are stationary signals and the non-stationary signals. After that, we just studied the various types of transients, that is impulsive transient and the oscillatory transient. As there is very little difference in between them, that impulsive transients are appearing at any one side of the waveform, that is positive or negative, but in case of oscillatory transient, they are occurring at both the side of the waveform, both the polarities, a positive and negative. Then further we discuss the long duration voltage variations, that is under voltages and the over voltages. Next topic was a short duration voltage variations, that is sag and swell, and finally we studied what is meant by voltage imbalance in three-phase unit system. In module number 3, we are going to cover the concept of flicker, what exactly the event flicker in a power quality. Then next event is notches or notching. Then next is DC offset, and last we are going to cover the harmonics. So let's understand the first phenomenon from the model number 3 is the flicker. Now flickers are basically the impact of voltage variation which is caused due to certain loads in a power system. Those loads are taking a current which is continuous in a rapid variation. Means these loads basically taking a current which is very fluctuating in a nature, and due to that fluctuating nature of the current, of course the terminal voltage across that load is also varies. And if these variations of voltage is supplied to any other load such as incandescent lamp, then you can observe here these lamps are maybe flickering like this, and that flickering, it may be perceived by the human eye. That means normally we can see that fluctuation in a light from the incandescent lamp. So such phenomenons which are basically occur due to voltage variation into the power system are called as the flicker. Now the wave shape of a flicker, it is somewhat like this, that is it is continuously varying. There is no such a type of continuous pattern is there, or we can say there is no any kind of direction. Maybe it may be for positive direction, maybe for negative direction. And another point is that the voltage fluctuation is an electromagnetic phenomenon, but still the flicker is the result of voltage fluctuation in some loads. That means the name flicker, it is given from the some characteristics are seen from the incandescent lamp, and that's why we can say this is the cause of voltage fluctuation. Now the next phenomenon which exhibits into the power system of power quality event is nothing but the DC offset. Now DC offset is a presence of DC current into the AC power system is referred as DC offset. It is quite hard to imagine that how it is possible that any kind of DC current will be merged into the AC power system. The reason behind it is it occurs due to the geometric disturbances which is caused by the electronic power converters. Because in case of power converters, the grounding voltage of various equipments is different, and it may possible that due to the current, direct current is mixed with the AC power system. This DC offset is basically affect in some example, that is here one example is considered, that is in case of incandescent light bulb life extenders, diode circuits are used, and if such kind of DC offset is there into the AC power, then what will happen, that suppose if we observe here, this is the DC offset of 3 volt which might be poured into this particular voltage signal, and due to that, whatever the original path of the voltage, this blue signal indicates the no offset signal as here indicated, and this green one indicates the after DC offset of 3 volt waveform is slightly shifted over the blue line. And what is that shift? As we observe here, if you consider this particular positive part where your 3 volt DC voltage supply is added into the actual sinusoidal waveform, and that's why here is the addition of the waveform. But here in negative half cycle, what happened, this particular DC offset of 3 volt is positive and the cycle is negative. That's why obviously positive negative becomes negative, and your actual sinusoidal voltage becomes slightly less, or you can say it is subtracted from the actual negative waveform. So that's why it is slightly shifted over the actual blue line. This blue line indicates the a signal, AC signal without any kind of DC offset, and after adding this 3 volt DC offset, the green signal is this one. Means basically your actual signal, it is changes its shape into uneven category, like positive half cycle is quite more than that of the negative half cycle. Negative half cycle part is only this one, but positive half cycle part is quite more. So it is we can say that the example which is caused due to the DC offset. Now if such kind of signal with DC offset is provided into circuitry where diodes are used, so there might be effect that whatever the voltage required for to lighten that particular lamp might be reduced, as in case of negative half cycle you can see. So for positive half cycle it may get a voltage more than required, but in negative half cycle the voltage is reduced, and that will be, we can say that, the effect due to the DC offset. As we know that if by any means DC current is entered into the any structure which contains the core and the winding structure, in that case core may get saturated. So same thing happens here with the transformer also. If any direct current in AC network is entered into the any transformer core, so obviously the core gets saturated, as because we know that the transformer is working on the mutual induction principle. Then of course if this saturation occurs, so heating losses will be there, then transformer life may get reduced. Next part, the causes of DC offset is erosion of the grounding electrodes due to the electrolytic process, as it causes the deterioration of the metal when there is a direct current into the grounding electrodes. The commutation is the phenomenon where one SCR is turned off and trigger to the other SCR is provided. Now during this shifting of current from one particular limb to the other, this particular notching phenomenon is occur. As we can observe here, in this diagram of rectifier, three-phase rectifier. So here suppose initially VA and VB, this particular voltage is dominant, then obviously the path of current will be from VA, this SCR, then through the armature and then through this voltage VB. Now when VAC, this line voltage is dominant, in that case VA, then this armature current and then through the VC. So means what happened? Initially when VAB is dominant, these two SCRs are working, and when VAC is dominant, at that time this SCR is remain same, but instead of this SCR will be in a on position. Means the shifting of current from this one to this one is nothing but the commutation of this middle SCR. So basically when this shifting is occur, at that time notching is created, and this notching signal is looking like this. There is very slight deviation of the waveform, but still it is continuous in a nature. That means it is just like a harmonics. But in case of harmonics we can predict the wave shape ahead, but here in case of notching it is not possible to predict the wave shape ahead. So that's why it is continuous in nature, but and also it is a sign that in this waveform harmonics are present. So we can predict that if notching is there, there is a possibility of harmonics in such power system. But it is also important to understand that you cannot measure the notching phenomenon with the equipments which are used for the harmonic analysis, as because as said earlier, it is occur for very small instants, and also it is non-predictable. So that's why some special kind of instruments we can say required for the measurement of notching and for the detection of the notching. Now let's understand the harmonic distortion. Here basically there might be voltage distortion or the current distortion. Now this harmonic distortion is very huge part of the power quality, as because 70 to 80% of the problems of power quality are due to the harmonics, and that's why the more weightage also given in this particular course on the harmonic distortion. As we will see in unit number 4, the detailed discussion regarding the harmonics introduction, then certain effects on various power quantities, and in unit number 5 we will have the analysis of the harmonic and the how to design a filter. So as 2 units is separately given on a harmonic study, so you can gauge what kind of importance this particular event has. So basically harmonics are nothing but the power frequency change into the fundamental signal. Now according to the transmission system, there should be no losses more than 1%, but still there are certain distortions are observed near to the load, and this distortion might be less when we go away from the load. In some cases the distortions are random, and most distortions are periodic. So whenever a distortion is an integer multiple of power system fundamental frequency, then such distortions are called harmonics. Now what is the meaning of this definition? If you observe here in this diagram, so this outer circle indicates the fundamental 50 Hz frequency, and these small circles here indicates the harmonics of different multiple frequencies. Now if you closely look at this animation, you will come to know that when this fundamental completes one particular its cycle, at that time The small circles here, some might be completing 3 of its cycles around him, some might be completing 5 cycles around him. Means what? There are such a signals which having the frequency of multiple of the fundamental. That means if fundamental is of 50 Hertz, then of course the third harmonic will be having the frequency of 150 Hertz. Then fourth will be have 200 Hertz. Then fifth will be of 250 Hertz. So likewise, there are certain signals which are mixed with the fundamental and they causes the resultant waveform like this. We will have some another diagram on it, that is the distorted signal analysis. Here we can see this is the fundamental signal. So here normally for the Indian frequency it is of 50 Hertz. The H indicates H is equal to 1, that is fundamental signal. Then third harmonic signal, which is of, if it is 60, then third harmonic will be 180. Then fifth will be of 300 Hertz. And if we all combine them up to H13, that is 780 Hertz, then combination of these all waveform will be like this. Means this particularly sinusoidal is added with the signal of 180 Hertz, 300 Hertz, 420 Hertz. If we combine all of them, then the combination of signal will be like this. Now where it really affects? So basic cause of harmonic is nothing but the non-linear load. So what is mean by non-linear load? We'll understand it first and then again we will go to the harmonics point. So non-linear load are nothing but the loads which are not taking current in proportional to the applied voltage. Means suppose if we take example here, one non-linear resistance is there, and if we supplied the voltage of sinusoidal to him, but it is not taking the current as in the same proportion of the voltage likewise a sinusoidal manner, but it might be taking a current likewise this. That means somewhere it is the shape is we can say very peak to peak current he might be drawing. So such type of devices are basically called the non-linear devices. And in power system it is said that the most causes of harmonic are nothing but the non-linear loads. Now non-linear loads are anything that which consumes a current which is non-proportional to the supplied voltage. So if we, as we seen in module 1 itself, that there are certain loads which are taking a current which is non-proportional to the supplied voltage. In that case various power electronic devices are come, and these power electronic devices are basically the non-linear loads. So here some examples of non-linear loads are discussed. First is single phase power supply. So single phase power supplies are basically supplies where we required the DC power supply for actual load, but it's been supplied through the AC power. So in such cases just like UPS and battery converters, in those cases you will observe the nature of current like this, and you can observe here the various harmonic levels into that particular current. Similarly, some adjustable speed drives for the elevators are there which taking the current in such a manner. The most of the part of current it is a flat line where current will be 0 and suddenly they are taking current, and that's why we can say that the actual wave shape of the current is varying, and due to that there are a tremendous amount of harmonics are observed into the power system or in that current. The next is three-phase power converter. Just like a single-phase power converters, three-phase power converters also creating the much more harmonics. Now here the summary of all PQ events, power quality events, according to IEEE standard 1159 is given. As the introduction of the power quality event, we are seeing very quick definitions of every power quality event. But if we go in much detail, then you will observe that again impulse is here. One example we will discuss, that is transient. So in transient also there are three types: nanosecond transients, microsecond impulsive transients, and millisecond impulsive transients. You need not to bother about this chart, because such a depth kind of definitions will never ask in examination. It is just for your information. So whatever the definitions or terms which might be asked into the examination, they will be the introductory kind of. So you need not to remember all these stuffs, that is for the duration or nanosecond or microsecond it will occur in a system. No need. It is just like summary of all those events according to the IEEE standard. So it is just for our extra information. So let's move towards the summary of module 3. That in module 3 we covered the introduction to flickers, the DC offsets, the notching, and the basics of the harmonics. Now students, you can check your understanding from this assignment, that what is the flicker and how it is caused, where does DC offset affects, that when DC affects is there in a system, at that time how it affects to the various equipments. Then what is the difference between notching and harmonics, and third, explain the concept of nonlinear load and the harmonics. So with this we are ending our module number 3. So while studying module number 3, if you have any queries, you can write them to me by the email ID, that is hadpe.somnath@gmail.com. Thank you very much.